Greetings everyone, my name is Bhavish Matawa and I will be presenting you my final year project, the Home Automation System. A system will generally consist of a main system and a backup system. The first system will be mostly used because of its user interface and the variety of features provided. In this case, I have used the Raspberry Pi 3 Model B with the LEDs acting as electrical components and the PIO sensor HCSR501 motion sensor as a security feature. Also, climatic conditions such as temperature and humidity will be recorded using the DHT11 sensor. The interaction of the electrical components will be made through the user's mobile and using the application Blynk. After the installation, you can configure your project name and then you can choose your device type, and this is the Raspberry Pi 3. And in order to interface between the microcontroller and the devices, we are going to use the authentication tokens that are sent to the user's mail. After setup and installation, we can drag and drop widgets onto the dashboard. Here we have used two switchers widgets assigned to GPIO27 and GPIO7 that is linked to device 1 and 2. Initially, the server is offline, so we have to create a Blynk server on the Pi for interfacing. It is also to be noted that each connected electrical components are powered by the GPIO pins and connected with a 1 kilo ohm resistor.
To gain access to the Raspberry Pi, we use remote desktop on the Raspberry's local address. First, we install the packages for the GPIO pins using sudo apt get install wiring Pi. Second, to create the Blynk server, we must import the Blynk libraries from GitHub. The GitHub is installed on the Raspberry Pi using the following command: sudo apt get install gitgo. We can now import the Blynk libraries with the following command: the git clone command. Now, to start the server, we go to the Blynk library directory using the cd command. The server is initialized, linking the user and the Pi through the authentication token. The server is now set online.
The Blynk server in the Raspberry Pi is now activated and interfacing the devices is possible. So we'll test the device 1 and 2 with a simple touch on the Blynk app. On. Device 2 is on. The same is repeated to turn off the devices. Always ensure that your mobile phone is connected to a Wi-Fi network or has access to the internet via mobile data.
Now proceeding to the first sensor is the DHT11 sensor. The DHT pins are connected to the GPIO4 where data is received, and it is powered by a 5V pin from the Pi to the sensor. In the code, the time library is imported to handle the timed operations where checks are done every 2 seconds. Also, the sensor naturally has some reading errors. The pause statement ignores the small errors and prints the received values as follows. The program is run using the Python command. The results show the temperature being at 22 degrees Celsius and the humidity being at 95%. The second sensor is the PIO motion sensor, which is programmed as follows. First, in the desktop, we create a bash file which contains an API. The API is used to get or post data from the sensor to the pushbullet app, and it is linked using the following access token. The GPIO and time libraries are imported. GPIO7 is connected to an LED which acts as an alarm. GPIO21 gets the data from the sensor. The os.system is given access using chmod 755 pushbullet sh, where the data is get using API REST. The data is sent to the push bullet mobile application in the user's mobile whenever a motion is detected. The following is done as follows. And now we're going to place my hand in front of the sensor. Here you can see the message will be sent to the user's mail, which is linked to the push bullet app in the mobile.
The IFTTT is installed on the user's mobile in order to constantly update the applet that links Google Assistant to the particular cloud. The if statement is linked to the Google Assistant and the particular cloud is linked to the then statement. Whenever the specific command is called on the Google Assistant, this feature or event is triggered on the particular cloud. Let us test the Google Assistant feature. Okay Google, turn on lights.
Okay Barvish, turning on device 3. The lights.
Okay Google, turn off lights.
Okay, turning off device 3. The lights.
Okay Google, turn on lights.
Okay Barvish, turning on device 3. The lights.
Okay Google, turn off lights.
Okay, turning off device 3. The lights.
As we can see, this is an essential security feature that provides necessary logs of triggered events on the particle interface.
The DTMF backup system is realized using the Arduino Uno board. The DTMF pins A1, A2 and A3 are connected to the digital pins 2, 3, 4 and 5, and the pins 6, 7, 8 and 9 are connected to the inputs of the relay module. Also, the Arduino board will be powered by a 9V battery. The code is uploaded onto the Arduino using a USB Type-B cable. After the connection, go to the Tools section, select the board to Arduino Uno and choose the port to upload the code. The 9V battery is used to power up the Arduino. Afterwards, use an auxiliary cable to connect the DTMF module to your 3.5mm head jack pin. The system is easily set up and now ready for use. Go to the dial pad and tap on the button 1 to trigger relay 1, button 2 to trigger relay 2, button 3 to trigger relay 3, and 4 for relay 4. In order to turn off the relay 4, tap on the button 8, and 7 to turn off the relay 3, and 6 to turn on relay 2, and 5 to turn on relay 1. Any electrical component can be used and connected with the relay module and automated. Let's test the automation via a phone call. The phone call will call to the other mobile phone linked to the system. The results show that we can still control our devices through a simple phone call, anywhere all around the world. That is all for the project, and thank you for your kind attention.